SpaceX headquarters in Hawthorne, California. Welcome to our webcast coverage for the launch of SiriusXM's SXM-7 satellite. You may know SiriusXM for its ad-free, curated music channels, or for its use of satellites to provide users with digital audio radio services. Today, to replace existing satellite services, SpaceX will launch the company's next-generation high-power broadcasting satellite, SXM-7. Following today's launch, the SXM-7 payload will join 5 other satellites in SiriusXM's active satellite fleet. After joining the fleet, there's an expectation that the payload will replace the XM-3 satellite to help ensure continuous and reliable delivery of SiriusXM's audio, entertainment, and data services to consumers in the United States. This effort will also help SiriusXM expand services to consumers in Canada and the Caribbean. Today's launch marks the 25th SpaceX mission this year and the 7th flight for this particular booster, which is pretty exciting. So with that, let's take a closer look at that vehicle for today's mission. So there on your screen, you have a look at our launch pad located in Cape Canaveral, and you see a healthy Falcon 9 cycling through its launch day processes in preparation for its 12:55 p.m. Eastern liftoff. Falcon 9, our 2-stage liquid-fueled launch vehicle, sits on Space Launch Complex 40. It stands about 229 feet or 70 meters tall, which is a little bigger than the wingspan of a 747 airplane. The bottom 2/3 of the vehicle is what we call the first stage. As I mentioned earlier, it will be taking flight for the 7th time today. The first stage is responsible for accelerating the vehicle all the way through to the edge of space, where it will drop off the second stage along with the payload. Once the drop-off is complete, we'll attempt to recover that first stage on our drone ship. Just read the instructions, which you see there on your screen, which is currently positioned out in the Atlantic Ocean. If we stick the landing today, it will mark our 69th successful booster recovery. About 2.5 minutes into flight, the first and second stage will separate, and the second stage will ignite its single Merlin vacuum or MVAC engine to carry the SXM-7 satellite to a highly elliptical orbit. Separation from second stage will occur about 4,000 kilometers above Earth, and then the satellite will perform burns to raise its position to enter a circular medium Earth orbit, or MEO, and reach an apogee of about 20,200 kilometers above Earth. At the top of your screen there, you can see a nose cone-shaped object that sits atop the vehicle. That's the payload fairing, and housed inside there is the SXM-7 satellite. The fairing measures 17 feet, or about 5 meters in diameter, and about 43 feet, or 13 meters tall. The payload fairing protects the satellite from aerodynamic heating, loads, and contamination during ascent. Once we get into the vacuum of space, the payload will no longer need that protection, so we'll jettison the fairing halves to save some weight as the second stage continues on with the satellite to its targeted drop-off orbit. The fairing halves that you see there, we used them on a previous mission. This is the second time that they are being flown. Both halves previously supported the K-MILSAT-1 mission back in July earlier this year. Due to upgrades on our recovery vessel, Ms. Chief, we'll retrieve one of the fairing halves with our recovery vessel, Ghost Searcher, and then attempt to catch the other half using our recovery vessel, Ms. Tree. The large truss structure that you see on the pad next to Falcon 9 is called the Transporter Erector, or TE. The TE is used to roll out Falcon 9 from the hangar to the launch pad and then raise Falcon 9 to its vertical launch position. The TE also routes power, fluids, and communication to both the rocket and satellite. So now that we've gone over some of the hardware that's essential to executing this launch, let's take a closer look at today's payload. Weighing in at almost 7,000 kilograms and over 100 feet long when its solar arrays are completely deployed, the 27-foot-tall SXM-7, built on Maxar's 1300 class platform, is designed to provide service for more than 15 years. This satellite's unique design also features a large unfurlable S-band reflector to broadcast audio and data signals to users on the ground. By joining SiriusXM's already active fleet, the SXM-7 will deliver the highest power density of any commercial satellite on orbit. This new satellite will send more than 8,000 watts of content to the continental United States, Canada, Puerto Rico, and the Caribbean, which in turn provides users with better signal quality and broader reach. Now, as the clock continues to count down, we're approaching T-minus 7 minutes and 45 seconds. We're looking forward to an on-time liftoff. Let's take a moment now to learn a little bit more about SXM-7. Prior to the start of our webcast, our Falcon 9 team performed functional checkouts for the SXM-7 satellite. At T-minus 38 minutes, the team concluded their electronic go, no-go poll and gave the okay to proceed into propellant load and launch. To keep both stages of the vehicle cooled as much as possible close to launch, the team at Cape Canaveral began loading propellant at T-minus 35 minutes. Since the second stage Merlin engine is very similar to the first stage Merlin engines, both the first and second stages get to use the same propellants. Our fuel is a refined form of kerosene known as Rocket Propellant 1, or RP1, and our oxidizer is super chilled liquid oxygen, LOX. We chill the liquid oxygen to be as cold as we can get it, which allows us to load more LOX and makes it super dense with oxygen molecules. Both of these things give us better performance with those Merlin engines. This also helps us to avoid the need to continue topping off prior to launch in order to make up for losses due to boiling. Now at this point, second stage is fully loaded with RP1, and the first stage looks like it is complete as well. Also, at this point in time, liquid oxygen is being loaded onto both the first and second stages. We're also loading helium into the storage vessels on the first and second stages. During flight, we pass this cold helium through heat exchangers on the Merlin engines. The heat of the gas generator exhaust turns that cold helium into hot helium, therefore expanding it. That expanded helium gas is then used to fill the empty volume in the tanks created by the engine pumps that pull the propellant out of the stage. Very shortly, we'll open the pre-valves between the first stage engines and the propellant tanks. We started to do engine chill-in. You might have heard that call out a couple minutes ago, around T-minus 7 minutes. Basically, by opening those valves, we allow some of that super cool liquid oxygen to flow into the turbo pumps, which helps us to avoid any thermal shocks that might occur when we start those pumps up at T-minus 2 seconds to light the Merlin engines. And it looks like we got some strong back transporter erector action there, slightly moving backward away from the rocket. So we're currently at just under T-minus 4 minutes. Everything appears to be on track for our on-time launch. The range is green, and as for weather, we've been keeping an eye on those upper altitude winds today, but right now, everything is looking favorable. If for some reason we have to call a hold on today's launch, we have a backup opportunity tomorrow with a liftoff time scheduled for about the same time. But as for now, all systems continue to be go for a liftoff at 12:55 p.m. Eastern. So first stage fuel loading completed on time around T-minus 6 minutes. And we're currently waiting for that first stage LOX load to complete. You should be hearing the call out for that any moment. And second stage liquid oxygen loading will complete around T-minus 2 minutes. Just a minute before liftoff, you'll hear the announcement that Falcon 9 is in startup. This announcement means that the rocket's own internal computers are now controlling the launch countdown on Falcon 9. Once the engines are confirmed to be at full power, the flight computer on the second stage will then command the ground hold downs to release the rocket right at T0. Our satellite team continues to monitor the health and status of that SXM-7 satellite located there in the fairing that you see on your screen. Currently, all systems are go on the satellite. The range continues to be green for launch, and weather continues to look good.
Hold on the primary countdown. That
launch board's running.
As you just heard, we did hear a hold called out today. The clock is stopped at T-minus 30 seconds. We're going to check in with the teams. Give us a moment and we'll see what we can get you. As you just heard on the countdown net, we had a hold called at T-minus 30 seconds. Prior to that, the countdown was proceeding nominally, keeping in mind that the purpose of the countdown is to help us catch any potential issues prior to flight. There are 1,000 ways a launch can go wrong and only one way that it can go right. Given that we are overly cautious on the ground, and if the team or the vehicle sees anything that looks even just slightly off, they'll stop the countdown. Overall, the vehicle appears to be in good health, but that will be ending our launch attempt for today. Keep an eye out on our social media accounts for the announcement of our next launch opportunity. Until then, thanks for joining us, and we'll see you next time.